All right, we're winding down now. I'm starting to peter out myself, so I feel you. I feel you right now. Okay, we're on 30 now. So problem number 30. You've got a rectangle on the coordinate plane, and they want you to find the coordinates of E. So if we reconstruct our coordinate plane here, we've got, here's our rectangle, and R is -5, -3. E is what we're looking for. C is at 9, 2, and T we're probably going to have to find at some point. So they're looking for part A, the coordinates of point E. Well, E definitely goes over the same amount as C, so we're definitely going over 9. And it's going to go down the same amount as R, so down -3. So there we go, 9, -3. That wasn't too bad. All right, B wants us to find the area. So the area of a rectangle is just base times height, or length times width. We can do LW, whatever you like. Which means we're going to need to do the distance, or find the distance a couple times. I think we can avoid using the distance formula simply because we have vertical and horizontal lines. We don't have any slopey, slanted lines. So how many units is R to E? So we can just take a look at our x coordinates. We're going from -5 to 9. So that would give us 5 units here plus 9 more units. So that's a total of 14 units. So I'm going to do that in a different color. This is a total of 14 units on this side. And we're going to do the same thing for C to E, only let's take a look at our Y units. So we have 3 units from E to the Y-axis, and then another 2 units, it looks like, from the Y-axis to C. So 3 and 2, that gives us a 5. So this is a 14 by 5 rectangle, which means our area equals 14 times 5, so that is 70. All right, and then part C wants us to find to the nearest tenth the length of our C. Okay, so now we're getting into something that is sloped. All right, so that's our distance formula problem right there. So the distance equals, refer back to another problem where we did the distance formula if you need to continue to memorize it. Tattoo it on your eyelids so you can study it. You need to know the distance formula, but remember it's closely linked to the Pythagorean theorem. Here we go. -5 minus 9, quantity squared, plus -3 minus 2, quantity squared. Okay, that gives us, that's a -14 squared. Is that, oh, I know this one. 14 squared, 196. Plus, that'll be a 5 squared is 25. So that is the square root of, let's see, 221. Was that 11? Like I said, I'm getting tired. It's been a long day, people. All right, is that 11? I hope it's 11. No, it's not 11. Oh, that would be 121. See, I told you it was late. I'm sorry. So we have to do a little approximation. So that is approximately 14.9 units, whatever the units are, boxes, miles, whatever. All right, so that was 30. 31. Here we go. All right, 31. Show that the quadrilateral quad is a rectangle. So a rectangle, we have to have at least one right angle and two sets of parallel sides. Okay, here we go. We're finding slopes. So we're going to look at QU, the slope of QU. So we've got -4 minus 11 over -1 minus 4. All right, -15 over -5, so 3 for that slope. And then the slope of UA, I'm just going to find all four of them. So we've got 12 minus 11 over 1 minus 4. So that gives us 1 over 3. Oh, we are doing negative opposite reciprocals here. And then we need the slope of AD. So that is 12 minus a negative 3 over 1 minus a negative 4. So that's 15 over 5. So, oh, there's 3. So these guys are looking parallel to me, and these guys are looking like they're perpendicular. Let's take a look at the slope of QD. Negative 4 minus a negative 3 over negative 1 minus a negative 4. So negative 1 over 3. Hey, look at that. We've got a set of parallel right here and another set of parallel right here. And then these guys are perpendicular. These are opposite reciprocals. These are opposite reciprocals. These are opposite reciprocals. So we have a rectangle. Okay, that was 31.